All right. Hey, everybody. We're going to have our first actual day of instruction here. So hopefully you've been finding your way around Schoology. Hopefully Schoology is working better today than it did yesterday. If you watched the video from yesterday, you saw a little sneak preview of what we're going to be doing today. We're going to be taking a look at irregular figures. So we could do triangles and trapezoids and rectangles and circles and all different kinds of shapes that we do have formulas for, but the key thing to point out today is that we do not have formulas for the shapes we're going to be doing because they are irregular. So we're just going to have to use the formulas that we have already and use that to figure out the area of shapes like this one. Here's a quadrilateral. It's not a trapezoid. It's not a parallelogram. It's not a rectangle, but we can break it up into shapes that we can find the area of. So I'm going to do that. Let's see. I'm going to use a couple lines here to show you how I'm going to break this thing up. And when you're doing these types of problems, feel free to draw all over your papers and show what they look like. But I'm going to take this shape. I'm going to make a triangle over here, and then I'll make another triangle over there, and then another triangle over here. And like I mentioned yesterday, that leaves us with this shape that's not exactly a triangle. In the video from yesterday, go ahead and take a look at that one. I made a great big rectangle around the whole thing and then subtracted away the triangles from the outside. Instead of doing that for this one, I'm going to say that this triangle has a base of, let's see, counting the squares all the way over here, we've got a base of 10 and a height of 4. So 10 times 4 is 40, divided by 2 is 20. That's the area of that triangle. This one has a base of 8 and a height of 6. So 8 times 6 is 48, divided by 2 is 24. This little triangle over here has a base of 2 and a height of 3. 3 times 2 is 6, divided by 2 is 3. And then the problem we have here is that this isn't quite a triangle. So I'm going to add on to this part here and give myself this triangle that has a base of 4 and a height of 6. 4 times 6 is 24. 24 divided by 2 is 12. The problem is, by doing it that way, we've counted these two squares twice. So if I do 20 plus 24 plus 12 plus 3, I've counted these two squares twice. So I'm going to take away those 2 at the end. So 20 plus 24 is 44, plus 12 is 56, plus 3 is 53, and then I'll take away those 2 that I counted twice to get a total of 51 square units. That's one of the ways of doing this. There are certainly other ways of doing lots of these problems. The next one I want to take a look at is similar to one that we did previously. Here is an irregular figure. I don't even know how many sides there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got a decagon here. I've got a couple of sides that I haven't figured out yet. So to figure out how long this length is down here, I'm going to have to figure out how far I'm going horizontally the whole way as I make my way from one side to the other. So from this point over here to this point, we've gone 4 units. I'm going to make that a different color so we can see that a little bit more clearly. So 4 units there, plus another 2 units there. So 6 units so far, plus another 5 there to give us 11, and then 4 more there for a total of 15. Do the same thing, or at least a similar thing vertically, but this one's going to get a little bit tricky. And I think of this as altitudes. When I start here and I climb all the way up to the top, I've gone up by 6. And then my altitude doesn't change for a while, and then it goes up 4 more. So right now, this point up here is at an altitude of 6 plus 4, or 10. So if I go down by 6, this new altitude, this distance right here is only 4, because we've gone up by 6, and then by 4, and then down by 6. So I'm still 4 above the base. And so from there, an altitude of 4 added on to this 8 gives us a total height of 12. There's probably other ways that you could think about that, but that's one way for us to figure out those unknown sides. Then, when I ask for the perimeter, all we have to do to find the perimeter is add up all the side lengths. 6 plus 4 plus 4 plus 2 plus 6 plus 5 plus 8 plus 4 plus 12 plus 15. I'm going to cheat and use a calculator. I shouldn't say that. That's not cheating. That's adding up a whole bunch of numbers. That's why we have calculators. But when I add those up, I get a total perimeter of 66 units of measure, whatever that is, just adding up all of the side lengths. And then to find the area, similar to what we did in class before the long break, I'm going to separate this thing out into different rectangles. I think I'm going to go this way. I'm going to cut this one here. So I've got a 4 by 2. 4 times 2 gives us a area of 8. Let's see. Let's maybe break this one up this way. So I've got a height of 6, and then this length is 4 plus 2. So this is 6 and this is 6. Both of these multiplied together give us 36 for the area of that square. Let's see, this has a length of 4. I'm going to cut this one this way. We already figured out on the previous slide that this height is 4. So I've got a rectangle here that is 4 by 5 for 20. And then this great big rectangle over here has a height of 12 and a width of 4 for a total of 48. And then I add up those 4 areas, 8 plus 36 plus 20 plus 48 for a total area of 112 square units. I'm going to do U to the second power to stand for square units. It's not feet or meters, it's just some length that we don't know. And there we go. There's lots of ways that you could break that up. I know that when we did this in class, there were some people that split everything up horizontally. So maybe you would split up this rectangle going this way instead and multiply 4 times 8 to get this and 15 times 4 to get that. Certainly different ways that you could approach this problem. The next example I want to take a look at is find the area of the shaded region, similar to we did with a couple of circle problems. I'm going to do this one in 2 different ways. One way is to actually just find these 3 areas because they're all triangles. We've got formulas for the area of a triangle. I'm going to say this one has a base of 4 and a height of 2. So I can say 4 times 2, 8 divided by 2, which is 4. This one has a base of 2 and a height of 2 also. 2 times 2 is 4. And then divide by 2 because it's a triangle to get an area of 2. And then this one has a base of 4 and a height of 2. 4 times 2 is 8. Divided by 4 is 4. So 4 plus 2 plus 4 gives us an area of 10 square units. Another way that we could do this problem would be to find the area of the whole triangle and then take away the area of this square. This one gets a little bit tricky because to find the length of this segment, we're going to have to think of this as a right triangle, and we'll have to do the Pythagorean theorem, a squared plus b squared. This length is 2, and that length is 2. This is a right triangle because they're horizontal and vertical. So I can say 2 squared plus 2 squared equals the hypotenuse squared. 2 squared is 4. 4 plus 4 is 8. And so 8 is the length of the hypotenuse squared, and that's one of the side lengths for our square. So the length of that actual hypotenuse is the square root of 8. And this one's got the same thing. This triangle over here would have a base of 4 and a height of, a base of 2 and a height of 2 also. So this triangle up here would be the same as this little triangle down here. So it turns out that both of these lengths, both of the sides of this square are both the square root of 8. Which means if I want to find this total area, the area of the shaded part will be the area of the triangle minus the area of the square. I guess I'll have to use SQ to stand for that. So the area of the triangle, base is 6, the height is 6. 6 times 6 is 36, divided by 2 is 18. And then the area of the square root of 8 times the square root of 8. Well, the square root of 8 times the square root of 8 is 8. So 18 minus 8 gives us the same answer that we got on the previous slide, 10 square units. Or just one more way that I'll mention here, I wouldn't normally do this, but we've got this nice grid. You could just count the squares. You could say I've got 1, 2, 3, 4, 5 squares. Those two together make another one. These two together make another one. These two together make another one. Those two make one. Then those two make one. So I've got a total of 1, 2, 3, 4, 5 whole squares plus 1, 2, 3, 4, 5 half squares, adding up to 5 total squares. So 5 plus 5 will give you those same 10. And finally, last question for us to look at today. I want to find the area of the lane on a basketball court. Now, for those of you who don't know, on a basketball court, there's a lot of geometric shapes, lots of circles, lots of rectangles. But if I talk about the lane of a basketball court, I'm talking about this whole region here. This is where the players stand around when somebody's taking free throws. Now, the tricky part about this is that I've got a rectangle over here. That one's going to be easy, but then I also have this part of a circle, not a whole circle, because I already included this in the rectangle, but I've also got this half circle added on over here. So our strategy is going to be, let's find the area of this rectangle. That'll be easy, 12 times 9. And then I'll add on this part of the circle here, and that's just half of a circle. We've got a formula for the area of a circle, pi times the radius squared. And in this case, I don't know what the radius is just yet, but I know that the width of the lane is 12. That means this whole distance, the diameter of the circle is 12, which means I've got a radius of 6. So to find this area, I'll do 12 times 19 for the area of the rectangle, and then add on the area of the half circle. Whoops. 12 times 19, there's the rectangle, plus, I'm going to put a half out in front of this, half of the area of the circle. And we said that the radius of the circle was 6, half of 12. So pi times 6 squared. When I plug that into my calculator tells me that it's about 228.04. And in this case, because all of my measurements are in feet, I've just found an answer that is in square feet. 228 square feet, which sounds like a lot, but next time you're on a basketball court, actually measure out what 1 foot looks like, and you realize that 1 foot isn't that big compared to the whole thing. That's all I've got for examples for today. You've got a homework assignment that is due before I see you again on Thursday, so make sure you get that thing done, submitted through Schoology like always. You should be able to open it up through Kami. Hopefully Schoology is working better than it was yesterday, and hopefully everything is making sense. If it's not, let me know. Get in touch with me on the Schoology Hangout or send me an email. But good luck on this, and we will talk to you again virtually on Thursday. Have a great day.